Hi, my name is Ernie Ndeberger. I'm CEO and co-founder of Fluorescence company, and I would like to introduce my idea for the microtech boosters. So what you need is microparticles with a defined fluorescence lifetime to use as a standard. These are the Fluorescence instruments, and for the Fluorescence Polymer Jupiter, it's the larger unit. We need these reference particles. It is an airflow cytometer which can provide automatic real-time identification and is usable for the identification of a wide range of aerosol particles. It allows differentiation of more demanding pollen types, but also is reliable for identification of additional bioaerosols, particles, classes, for example, spores. Here is the principle of the instrument. It has an integrated pump. The air with the particle is aspirated and the particle is flying through the system and finally through the measurement chamber, and there it is measured with different measurement methods. First stage is a scattering for triggering the particle, detecting the particle, which starts then the second stage, which is a holographic setup, which takes two holographic images. The third stage is a fluorescence lifetime and spectra measurement unit, and at the end there is also polarization measurement stage. So for every single aerosol particle we measure in flight a rich set of data, and finally this is then used for identification of the class of the particle with machine learning algorithms. Here you see for example two holographic images of a particle in flight. And for the fluorescence, we use, for example, the spectral fingerprints to have information about the chemical composition. Here, information regarding this request. This concerns the fluorescence measurement, where we use the properties of autofluorescence. So this is a natural emission of light by biological structures or also other molecules, and they have this emission of light after appropriate excitation with high energy light, typically UV light. This instrument can measure two properties of this autofluorescence emission. The first is the spectrally resolved fluorescence intensity, but in addition also the decay time of this emission, which is called the fluorescence lifetime. So this gives additional information besides the morphological features about the particles, and we use that for the identification. Technical information, so the particles should be suitable for excitations in these ranges, 280, 365 and 405 nanometers. And as the instrument has spectral windows in the range of 320 up to 700 nanometers, also these particles should emit in this range. And the lifetime measurement, which is interesting us, is in the range of 0.5 to 20 nanoseconds. And also these particles should have an emission, a single fluorescence lifetime in this range. We are looking for a solution provider partner for such reference particle with defined fluorescence lifetime, usable for airflow cytometer calibration. What this means, I will show afterwards. State of the art is fluorescence standard particles with defined spectrum, but not with defined lifetime. For example, where we are with the instruments, we did a comparison of fluorescence lifetime. We used therefore fluorescein droplets, liquid droplets, and we could achieve preliminary results, which showed us, okay, the instrument is working, we can measure a lifetime, but what we need is more suitable reference material which is easier to handle, which is solid for field calibration and work calibration. Here are the requirements in detail. This is also on the call. They should have a defined shape. Spheres would be ideal, but could be all. It's not mandatory. The morphology should be defined and as possible as similar. Size range would be good to have different size ranges covered in this range, 0.5 to 100 micrometers. Excitation wavelengths I mentioned, emission range, the autofluorescence also. They should also have a good efficiency, a simple lifetime, and also what would be nice to have several different materials with the lifetime range for different lifetimes in the range of 1 to 10 or 20 nanoseconds. Very important, these particles should be long-term stable, solid material, easy to dry atomize, not stick together. Also, they should be payable, cost-effective, and very important, not toxic, so that no health hazards are a problem. Thank you very much for your time and interest. I hope you are interested. Here my contact dates you will find also on the platform. Thank you very much.